welcome to Tour of the Ear. I'm your host, Nathan Evans.
And I'm your other host, Kendall Bingham.
Thanks for joining us. First, we will start talking about the outer ear. Most easily seen is the pinna, or auricle, that is made up of cartilage covered with skin. There are many folds and depressions on the pinna that vary from person to person, but are mainly universal among all people. A popular place to get pierced is in between the helix and the scaphoid fossa. The pinna acts as a funnel to collect and direct sound down the ear canal, and 1/3 of that is cartilaginous, and 2/3 of that is bony. Fun fact, the ear canal is curved almost in an S shape and averages about 1 inch in length in adults.
The ear canal is also known as the external auditory meatus. Sound travels through this canal and hits the tympanic membrane, aka the eardrum, causing it to vibrate. Vibrations of the tympanic membrane are transmitted to 3 small bones of the middle ear called the ossicles. Fact, they are the 3 smallest bones in your body. First, the malleus transfers the vibrations from the tympanic membrane to the incus, which then pushes the stapes against the oval window, pushing it in and out, transferring the signal to the inner ear fluids. This motion of the ossicles converts the sound waves from the external auditory meatus from acoustical energy to mechanical energy.
The middle ear is an impedance matching system, meaning that it makes up for the resistance and loss of sound transition from the pinna to the inner ear. Without it, sound waves would reach the fluid-filled membranes of the inner ear, and it would sound like you were being talked to underwater.
The middle ear is your eustachian tube. This tube helps equalize the pressure in your ear, such as when you gain elevation. Without this important tube, your eardrum can burst. The eustachian tube also helps with the removal of debris and mucus from the middle ear. Moving on to the inner ear. As you remember, the stapes pushes the oval window in and out. This causes the oval window to communicate with the shell-like structure of the inner ear called the cochlea. The cochlea contains 3 fluid-filled compartments, the scala vestibuli, the scala media, and scala tympani. The scala vestibuli and scala tympani are in the bony labyrinth filled with a fluid called perilymph. The scala media is in the membranous labyrinth made up of endolymph. When the oval window is pushed in and out, it transfers the vibrations of the fluids of the scala vestibuli up to the apex of the cochlea, called the helicotryma, and back down through the scala tympani and out the round window.
Through this process, the Reisner's membrane, located between the scala vestibuli and scala media, as well as the basilar membrane, located between the scala media and the scala tympani, are shifting. The motion of these membranes moves the endolymph fluid in the scala media. Located inside the scala media is the important organ known as the organ of Corti. This is the sensory organ of hearing. Contained on this organ are the inner and outer hair cells, with hair-like projections called cilia on top. When these cilia are stimulated by the movement of the endolymph, they send nerve impulses to the auditory nerve, which aids in our ability to hear. The cochlea is organized tonotopically, meaning that the low frequencies are stimulated at the apex, and the high frequencies are stimulated at the base.
Our balance system also helps us walk, run, and move without falling. This balance system is also known as a vestibular system located in the inner ear. The inner ear consists of 3 semicircular canals that contain fluid and sensors that detect rotational movement of the head. Each of the semicircular canals lies at a different angle and are stimulated by different movements. The superior canal is stimulated by up and down movements. The horizontal canal is stimulated by side-to-side movements, and the posterior canal is stimulated by tilting from one side to the other. All 3 contain sensory hair cells that are activated by movement of the inner ear fluid endolymph. As the head moves, hair cells in the semicircular canals send nerve impulses to the brain by way of the acoustic nerve. The nerve impulses are processed in the brain and help us to know where we are in space or if we are moving. Balance and equilibrium help us stay upright when standing and know where we are in relation to gravity.
Whoa, I'm getting kind of dizzy.
For your enjoyment, our wonderful viewers
just send in videos of their animals with vestibular disorders. Knock knock.
Who's there?
Ears.
Is who?
Here's the end of our video.
Thanks for watching.